Alright, welcome back to Introduction to Regression Analysis. Starts 367 and Adebanji's notes. Alright, so KNUST September 30th, 2019. Alright, so we're trying to look at a simple linear regression. So remember that this regression course, you have to be able to find out that the two data points you have has some correlation. Okay, if there is some correlation between them, then it means you can go ahead and do your regression model. So if you want to look at a regression model between height and weight, the first thing you have to do is to run your correlation and see whether there is that correlation between them. If the correlation exists, then you can go ahead and do your regression model. Okay, so we're looking at simple linear regression. So we say that regression is a statistical method used to describe the nature of relationship between variables, that is positive or negative, linear or non-linear. So regression in general is some method that you use to describe the nature of the relationship, okay, between variables. Okay, so actually, whilst the correlation will just tell you that there's a correlation between them. Okay, when this moves, that moves. Okay, it doesn't give you detailed information how much change occur in x when y is changing. Right? It doesn't know all the time. It doesn't even give you that information in correlation, but regression does give you. Okay, regression does give you. So regression analysis is used to predict the value of one variable. So that's a dependent variable on the basis of other variables. So you would want to do a regression model because you want to do some prediction. Okay, so you are doing a business, and then you are maybe you buy soft drinks. Okay, but together with the soft drinks you add some free snacks. Okay, so you try to find out whether the number of free snacks that you get has something to do, has an effect on your sales daily. All right, so you want to be able to predict that if you bring in 10 snacks, how much money are you going to make in that day. All right, so to do that, you have to employ a regression analysis so that you can tell you, or you can predict to you that, okay, when you supply the company or the restaurant with 15 snacks, you are likely to get a sale of, let's say, 5,000 cedis, 500 cedis, 10 cedis. Okay, so that is actually done by a regression model. And then remember that in correlation we said that correlation doesn't differentiate which of these variables are dependent or non-dependent or independent, right? But regression would answer those questions and tell you that this man is dependent and that man is independent, right? So dependent variable, the variable which you are trying to explain using the independent variables, are mostly generated by what? Y. Okay, and then these are the independent variables, right? So the fact that we are doing a simple linear regression then means that our response variable, okay, our response variable, which is what is responding to our input variable, all right, y, is 1, and then we also have one independent variable. So there is one dependent and one independent. Okay, that is actually what we are looking at. So if we only have one independent variable, the model is like that. So this model you see here is actually what we call the simple linear regression model. Okay, simple linear. So now that you saw x and y, okay, you saw x and y, there are two variables, you did a correlation, you saw that they have some correlation between them, isn't it? Now you want to be predicting it. So like example I gave, then the number of free snacks you make available and then the sales you get. So you saw that, yeah, you want to be able to predict those, that so you actually did a correlation to see whether the number of snacks that you supply in a day has something to do with or has an effect on the sales you make daily, isn't it? So that for that information, then you have to go ahead and do a simple linear regression. All right. So we believe that the response variable, which is now in our case is the sales, is kind of a factor, okay, a factor, some multiple of what we are inputting into the system. So in our case, the free snacks that we are inputting in our system, okay. All right. So then our interest is to be able to estimate the constant, okay, those unknown variables, which is they are not variables, they are constant or known constant, the b naught and b1s, okay. This is what we want to try to estimate. So remember that the independent variables are provided, and then its effect on the the dependent variable is being observed, okay. So remember, when you have this model, the b naught, right, is called the intercept, okay. The b naught is called the intercept. So remember, this is a typical straight line formula. So when you are drawing a straight line, let us do this your Cartesian plane. Then if I draw a line like that, then if I see my intercept, then I'm looking at the point where my graph will cut the y-axis, okay. So that is that. So it means that if you are doing a regression model and then your data point are scattered like that, then the regression model will provide you with a line of best fit, okay. So let's say the line of best fit is that it's a straight line. So it means then this will be the intercept, which we are calling now b naught, okay. And then the b1 we are saying is a slope, okay. So slope is trying to check this steepness of the line, okay, right. So if the line is very horizontal, you don't get any slope, zero slope, all right. If it is vertical, it kind of very undetermined, you can actually find that, all right. So before you do a regression model, you must be able to check these assumptions, okay. So these conditions are required for a regression model, a linear regression model. So for these regression methods to be valid, then the following conditions for the error variable must be met, okay. So you saw that this is just an estimate. This is an estimate. We observe something. Remember that the example I give free snacks, I record the sales I get. I give free snacks, I record the sales I get. So already I'm observing those values, but I don't have that machine, that function that takes in the snacks and give me the amount that I'll earn in a day. All right. So I'm trying to estimate using this function. So there is always going to be this error, okay, error, which is going to be like a deviation from the main thing. So we are saying that the error must meet this condition. The distribution of the error must be what? Normal, okay. So we are saying that the error must be normally distributed. The error must be normally distributed. So the error must be normal, okay, Now if it is normal, what's the mean? It has a mean of 0 and then a constant standard deviation, isn't it? So let's see variance. So we believe that it has to have a mean of a 0, right? And then the standard deviation also a certain constant, which is a constant regardless of the value of x. Okay. And then the value of e associated with any particular value of y is independent of that. So the error that will be associated with some value of y will not be that which is also associated to some other value of y. Okay. So that is that. So the next thing we'll be looking at estimating the coefficients in a simple linear regression model.